Okay, right. So today we will discuss a vibration related problem. So the link to this problem is mentioned under the description. So let's focus. The first part is obtain the general equation for the magnitude of the vibration amplitude of a force damped system. Right. So let's sketch the system. So here we have mass m, right? So there is a kind of an excitation force that is acting on the mass, right? So let's say the force acting on the mass is P cos omega t, right? And this mass is connected to a spring and as well as a damper that is connected to the certain type of a base, right? So let's say this is the base, or you can say ground, right? Right. So now we need to calculate the magnitude of the amplitude, right? So because generally you are getting a formula to the amplitude with a sine or cosine term, right? But here we have to consider the magnitude of it. So let's write the equations of motion, or in other words Newton's law, right? So now in this problem, let's say the direction of the motion of the mass is acting towards the downward direction, right? So let's say x is the direction of motion of the mass downwards, right? So writing equations of motion for this system will be mx double dot acting downwards, right, equals there is a force that is acting downwards on the mass m, which is P cos omega t. And how about the other types of forces? Okay, so let's sketch the free body diagram, right? So now this is the mass m, right? And x is the direction of the displacement of the mass that is going downwards, x. So that means this mass is pressing the spring and as well as the damper. Okay, so now the mass is pressing the spring, so that means the spring is exerting a reaction force on the mass along the upward direction, right? So the force on the mass is acting along upward direction because of the spring, right? So what is the value of that force? That is kx, where k is the spring constant and x is the displacement of the mass, right? So like similarly, when mass m is pressing the damper is also exerting a reaction force on the mass along the upward direction, right? So what is the value of that? So the value of that force is cx dot. X dot is the velocity that is caused because of this displacement, and c is the damping coefficient. Now it's the spring force is acting along the upward direction. So but when considering the overall direction of the motion, because we have applied the direction of motion along the downward direction, so that force due to the spring is minus kx, right? Damper is cx dot, right? Okay, so from there I will sketch the free body diagram for you to have a better understanding. See, this is P cos omega t, this is kx, and this is cx dot, right? I think now you have a better idea. So be very careful. Every time when you are going to apply the equations of motion, you have to specify the direction, right? So in order to specify the direction, you have to have a clear idea about along what direction this mass is moving, right? Okay, so those are general considerations, right? So now what can you do? Okay, so let's take this minus kx and cx dot part to the left side. Then we can form a very nice equation. Mx double dot plus kx plus cx dot equals p cos omega t, right? So now let's divide the whole equation by m. So divide this by m, you will be getting x double dot, right? Then this k divided by m x. This is C divided by M x dot equals P divided by M cos omega t, right? So now you know K divided by M, let's write it here. K divided by M equals omega n squared, right? Those are fundamentals. Then C divided by M equals 2 beta omega n, where beta is the damping ratio, right? So you can substitute x double dot plus omega n squared x plus 2 beta omega n x dot equals P divided by M cos omega t. Okay, so now we have x double dot plus omega n squared x plus 2 beta omega n x dot equals P divided by M cos omega t, right? So now we are using the technique of D operators, right? So we know x double dot is the acceleration, or in other words, that is the second derivative of x with respect to time. We call it d2x divided by dt2, right? So according to the D operators, we call it d squared x, right? Because d square, because of the second derivative. Similarly, x dot, that is the first derivative of x with respect to time. We call it dx by dt, right? So with respect to the D operators, we call it dx, right? So here d to the power is 1 because of the first derivative, right? So now we are going to use the technique in here. So we can say d squared x plus omega n squared x, because you don't need any D operators there, here plus 2 beta omega n dx, right, equals P divided by M cos omega t, right? And now from here you can take this x out, because here x is common. So taking x out, here d squared plus omega n squared plus 2 beta omega n d equals P divided by M cos omega t. So now according to the D operator method, there is a technique that we use. So first of all, let's subject this x equals P divided by M cos omega t divided by this part, you can put to the denominator, d squared plus omega n squared plus 2 beta omega n d. So now here there is a technique, right? Here just consider this cos omega t, consider this cosine function, right? So here t is the time variable. So what is the coefficient of time variable? Omega, right? So as according to the technique, replace d square terms in the denominator by putting minus omega squared. So if you are going to consider the denominator, there is only one d square term. So replace that d square term by putting minus omega squared. That means P divided by M cos omega t divided by minus omega squared plus omega n squared plus 2 beta omega n d, right? So you can form a nice equation if you put the positive part to the first, that means omega n squared minus omega squared, then it looks nice. Omega n squared minus omega squared, right? So now according to the technique that we are going to solve this equation, we are going to multiply both up and down by the conjugate of this denominator, right? Because that is the procedure. So what is the conjugate there? If you consider this part as A, if you consider this part as B, so what is the conjugate? Conjugate would be A minus B, right? So it would be omega n squared minus omega squared minus 2 beta omega nd. Omega n squared minus omega squared minus 2 beta omega n. Okay, so x equals p divided by m cos omega t divided by omega n squared minus omega squared plus 2 beta omega n d, right? So this part we have to multiply by the conjugate of this, right? Omega n squared minus omega squared minus 2 beta omega n d is the conjugate of this, right? So we have to follow this step in order to proceed with the calculations, right? So multiplying this with that, we will be getting something like difference of two squares. That means again x equals omega n square minus omega squared whole thing squared minus 2 beta omega n d whole thing squared, right? So upstairs part will be p divided by m cos omega t multiplied by omega n squared minus omega squared minus 2 beta omega n d, right? So now again we are going to follow the technique that I have taught you when using d operators. So now I have previously taught you a technique that we are going to use with d operators, right? So if you have any cosine or sine term, so here we have cos omega t. So now here this t is the variable and omega is the coefficient of time variable, right? So if we have omega as the coefficient, according to the technique, we have to replace all d square terms by putting minus omega squared. That is the technique. So if you are going to use that technique, you can write p divided by m cos omega t as it is, and then this part also as it is, omega n squared minus omega squared minus 2 beta omega n d. Now here in the denominator, right, you can notice that we have a d square part, right? So that means this part you can again rewrite like 2 beta omega n whole thing squared times d squared, right? Okay, now this d square part you can replace by putting minus omega squared. Okay, so let's write that step in here. Omega n squared minus omega n squared you can keep as it is. Now I have taught you d square you can replace by putting minus omega squared. So minus 2 beta omega n squared. Okay, no problem. Here you can write minus omega squared, right? So now again this minus into minus will be positive, right? So you can rewrite this by positive, erase this 2 beta omega n omega whole thing squared, right? Okay, so now you can understand this expression. Okay, so from here I am again going to the top, right? So now p divided by m cos omega t we have, and omega n squared minus omega squared we have, and minus 2 beta omega n d we have, right? So now what you can do is, as I have taught you, here this d is an operator, right? So what is this d? That is actually the first derivative that defines the first derivative option, right? So d equals d by dt option, right? So this d operator you can combine with this cos omega t part, right? So that means d multiplied by cos omega t will be d by dt of cos omega t, that is minus sin omega t times omega, right? So now what I am going to do in the next step will be p divided by m you can keep as it is, no problem, right? Because you know that is a constant, right? You can multiply cos omega t by this and then minus cos omega t by this, okay? So p divided by m you can keep as it is, then I will put larger brackets cos omega t times this part cos omega t times omega n squared minus omega squared, no problem, minus 2 beta omega n d cos omega t, d cos omega t. Okay, so I will close the larger bracket and then divided by this part. Okay, omega n squared minus omega squared whole thing squared plus 2 beta omega n omega whole thing squared, right? So now I can erase this part, right? So now you know d times cos omega t, that is the first derivative of cos omega t with respect to time. So answer for that you know. So let's write the next step from that. P divided by m. Here there is no any sort of simplification. You can write as it is, cos omega t times omega n squared minus omega squared minus 2 beta omega n. D of cos omega t will be minus sin omega t times omega, right? And the denominator will be the same, but we have to write omega n squared minus omega squared whole thing squared plus 2 beta omega n whole thing. So now we have x equals p divided by m cos omega t times omega n squared minus omega squared minus 2 beta omega n times minus sin omega t times omega divided by omega n squared minus omega squared whole thing squared plus 2 beta omega n whole thing squared, right? Okay, so now let's simplify that. P divided by m cos omega t times omega n squared minus omega squared plus sin omega t separately times 2 beta omega n separately, close the brackets, divided by omega n squared minus omega squared whole thing squared plus 2 beta omega n whole thing squared, right? So now the next target is to form a trigonometric expression, right? So in order to do that, divide this part by square root of this squared plus this squared. That means omega n squared minus omega squared whole thing squared plus this part 2 beta omega n whole thing squared, right? This also by square root of this squared omega n squared minus omega squared whole thing squared plus this part whole thing squared 2 beta omega n whole thing squared, right? So if you divide like that, in order to balance the equation, this ultimate denominator also you have to divide by that, divided by square root of omega n squared minus omega squared whole thing squared plus 2 beta omega n whole thing squared, right? Okay, so now let's consider this part as a cosine term. So let's say this part that is what we consider as a trigonometric ratio. Let's call it cos phi, right? So let's say this trigonometric ratio as sin phi. Okay, so now if you divide this part by this square root of this component, then you will be getting something like this. Okay, if you divide like that, you will be getting something like that. So let's write it here. omega n squared minus omega squared whole squared plus 2 beta omega omega n whole squared. Okay, right. So now this we considered as a cosine ratio, and this we consider as a sine ratio, right? Okay, such that tan phi, because usually when you are going to define trigonometric ratios, it's better to define the tan angle, because like in the examination, your marking examiner will offer some marks on that, right? That means if you are going to define trigonometric ratios, better define the tan angle. Tan phi equals, so then what is tan phi? So tan phi, in that case, tan phi will be 2 beta omega omega n divided by omega n squared minus omega squared. Okay, so that means phi equals tan inverse 2 beta omega omega n divided by omega n squared minus omega squared, right? Okay, I just call that. So now it's very easy. This part you can replace by cos phi. So I am going to erase that. Okay, okay, right. So this part now you can write cos phi plus. Okay, so this part you can write by sin phi. Okay, omega t times sin phi. Okay, divided by this, right? So let's write that neatly. P divided by m cos omega t cos phi plus sin omega t sin phi divided by square root of this omega n squared minus omega squared plus 2 beta omega omega n whole squared. So now what can you say? Cos omega t cos phi plus sin omega t sin phi. So then this part you can replace by, I hope you can remember the formula, cos alpha minus beta. You remember that? What is that? Cos alpha cos beta plus sin alpha sin beta. The same formula you can use here, right? So that means you can replace this by, see, that is how we simplify. Cos omega t minus phi, right? So now you can again simplify that. Let's see how to simplify. Right, so now you have to be a bit careful, okay, in this part. Okay, so now also you know that k divided by m equals omega n squared. Okay, so that means what is m? M equals k divided by omega n squared, right? So this m also you can replace by, here you have p divided by m, right? So that you can replace by k divided by omega n squared, right? Okay, so I will write that again if it's not clear. P divided by k divided by omega n squared, right? Okay, so that means this omega n square part you can include inside this square root symbol. Okay, so that means it's something like this omega n square part you can include inside the square root by omega n to the power 4. Okay, so then here you will be getting only k, you will be getting only p divided by k. Okay, Now shall we try to finish the simplification? Okay. So we have P divided by K cos omega t minus 5, right, divided by this part. So if you divide this by omega, this part by omega n to the power 4, and also this part by omega n to the power 4, basically you will be getting something like how to say that, right? Okay, focus this. Also, you know that we say omega divided by omega n as the frequency ratio, right? You know that. Okay, what is omega divided by omega n? Frequency ratio, that is R. Okay, you know that. So if you separately divide this part, that means omega n squared minus omega squared whole thing squared by omega to the power 4, and also this part also by omega n to the power 4, after simplifying you will be getting something like 1 minus r squared whole thing squared, right? Something like that, because r you already know, r is the frequency ratio omega divided by omega n. Okay, that is what you are getting. Remember to put the square root symbol. And what you would be getting here, you would be getting plus 2 beta r whole thing squared. Okay, so now we have obtained the general equation. So right, so let's erase this part and write it. So now you can say x equals P divided by K cos omega t minus 5 divided by square root of 1 minus r squared whole thing squared plus 2 beta r whole thing squared. 2 beta r. Yep. So basically that is the equation.